Let f of x equal 5x plus 4 over 4x minus 7. Find the domain in interval notation. So when I think of finding the domain, I think of finding like what would give us a problem here. So if we just took any function that is a fraction, so we're going to have a numerator and a denominator. If this whole fraction ends up positive, is that a problem? If we have some number on the top, some number on the bottom? No, that's not a problem. That's okay. What if we have some function, we'll say it's plus and plus or minus minus, it doesn't even matter. What if we have some other numbers? We have some number here, some number here, it ends up negative. Is that a problem? No. So any whole numbers or any parts of numbers are okay. What about if we have 0 in the numerator? Is that okay? Let's say I had 0 and any number in the denominator. We'll put 12, but it could be anything. Is this a problem? This one's tricky, but it is not a problem. We can have 0 in the numerator. So 0 divided by 12 equals 0. Okay, so the last case you're probably thinking, what if we have some number in the numerator? Doesn't even matter what it is, I'll just say 17 over 0. Is this a problem? This is a problem. We cannot divide by 0. I have a shirt that says it's all fun and games until somebody divides by 0. So try to remember that. We can't divide by 0. 0 can't hold anything up here, okay? So this is the case we want to be careful of then. So numbers can be positive, negative, but we just can't have the denominator be 0. So we're not really worried about the numerator here. This can be, we saw it could be 0, it could be negative, it can be positive. We are worried about the denominator. So we know whatever happens, 4x minus 7 cannot equal 0. So we want to find the value of x that would make 4x minus 7 equal 0. And so this is exactly what we're going to do, is set up the denominator so that it can't equal 0 and solve. So add 7 to both sides. So we get 4x, and we still want to keep that cannot equal sign. Cannot equal 7, divide by 4. And so now we know x cannot equal 7/4. So that's the value that will give us 0 in the denominator. So the problem is we still have to put this in interval notation. So if we put this on a number line, what would represent our whole function is we could have a line going clear down, and then at 7/4 we're going to have a little blip because it can't equal 7/4, and then clear up. So it could be any number except 7/4 to represent the range of the domain, or the range of numbers that can be the domain. So the way we're going to write that is we always want to write interval notation from least to greatest. So we're going to start at negative infinity, and it's going to have a clear run negative infinity up to 7/4, and then it stops. Now, do we want a parenthesis here or a bracket? Well, let's think about it. We definitely don't want it to equal 7/4, and so it's going to have to be a parenthesis because that shows it goes right up to 7/4, but it won't equal 7/4. So it can be that, or, so we want to do our little or symbol, it'll be then from the next run from 7/4 up to positive infinity. So again, we want a parenthesis there. It cannot equal 7/4, and then it'll go up to infinity. Again, a parenthesis around infinity, and that is the interval notation. So notice this is every single number except 7/4, and that's how this function will be okay. So this represents the domain for that function.